So our next problem is the integral of 5x plus 7 to the 100. Not that this is useful in many applications or anything, but it is a fairly nice example of u-substitution. Now you don't have to do u-substitution here. You could multiply this out 100 times, get a polynomial that involves 5x to the 100 plus 5x to the 99 times 7 blah blah blah. But that's a lot of work. Maybe u-substitution is a little shorter. So what would you say is u here? What is the inside function? Well, the stuff inside the parentheses is usually a good guess, right? So 5x plus 7. And then the next step we say is what is du? So that would be 5x plus 7 prime times dx, which is just 5 dx. You could say it's 5 times 1 plus 0, but then you would really want to simplify that down to just 5 dx. And then we'll rewrite the integral. So now instead of 5x plus 7 to the 100, I can just say u to the 100. Can I replace the dx with du? Well, du isn't equal to dx. We could say divide both sides by 5 here, so 1/5 du equals dx. So if I see a dx, I can replace it with a 1/5 du. And then what's the integral of u to the 100? It is u to the 101, 1 over 101, and then still have the divide by 5 plus c. And then that's not the final answer yet because we should substitute back. Get 1 over 101 5x plus 7 to the 101 times 1/5 plus c, and then you should check it by taking the derivative. All right, let's try another one. How about the integral of x to the 4th times 3x to the 5th plus 7 to the 100 dx? What would you say is the inside function? That's what we call u. So that would be 3x to the 5th plus 7. What's du? 3x to the 7th plus 3x to the 5th plus 7 prime dx, which is 3 times 5x to the 4th plus 0 dx. And here's the tricky part. What is, so can I just replace dx with du? No, they aren't the same. What I can do is move the 3 times 5. So say 1 over 3 times 5 du equals x to the 4th dx. So notice there I divided both sides by the 3 times 5, but I did not move the x squared over, or the x to the 4th over. So I have all stuff involving u on one side and all stuff involving x on the other side. So now can I replace the dx with 1 over 3 times 5 du? Well, not exactly, because dx isn't just equal to this, but x to the 4th dx is equal to this. And oh, look at that. I happen to have an x to the 4th just sitting there waiting to combine with the dx to give me 1 over, that I can replace out and get du. So if you need to, you don't have to, but if you want to, you can rewrite this as put that big thing first times x to the 4th dx, and then you can say, oh, x to the 4th dx, where have I seen that recently? And so that makes it a little more obvious that you can just substitute out the 1 over 3 times 5 du, substitute out the x to the 4th dx for this. So then we have u to the 100 times 1 over 3 times 5 du. Integral of u to the 100 is u to the 101, 1 over 101. Got the constant vertical multiplier there. And then substitute back. So we'd have 1 over 101, 3x to the 5th plus 7 to the 101 times 1 over 3 times 5 plus c. And then we would go check by taking the derivative. So that seemed like an awfully nice coincidence, right? That the derivative of the inside function, the x to the fifth, essentially, just happened to be sitting there with an x to the fourth. Would it work if we didn't have an x to the fourth? So what if we had integral of 3x to the fifth plus 7 to the 100 dx? Or what if we had x cubed 3x to the fifth plus 7 to the 100 dx? So it worked when we had a fourth power there, but would it work if we had a cubed power? Or what if we had x to the fifth? 3x to the fifth plus 7 to the 100 dx. The answer to all of these is nope. You need exactly the right thing hanging out there to combine with the dx to give you du. And it seems like at this point, well, why even bother with u-substitution if I need to be extremely lucky to have exactly the right thing there? Well, it turns out in a lot of applications, it does actually work out that you have exactly the right thing there to combine with the dx to give du. So it is actually worthwhile. There are lots of applications where it helps. And it's just the artificial ones here that make it seem a little like you just have to get fortunate, basically. All right, next time we'll look at some other u-substitutions.